Used tires are a real source of pollution. This pile represents about 100,000 of them. At any rate, these tires will have a second life. They'll be recycled to make rubber mats. Each day in this factory, they recycle 15,000 tires into mats. Tires have to be reduced to little granules, but first, this conveyor feeds the tires into the washer. Tires are washed with a water-based biodegradable preparation. Then they're sent to the shredder. The shredder has 2 rows of large teeth. These grind up the tires into pieces. This shredder is able to cut up almost 1,000 tires an hour. They come out as fairly good-sized pieces of tires, which are then shredded a second time. Metal is magnetically separated from the rubber, and the metal pieces are recycled at another factory. Other components of the tires, such as fiberglass and nylon, also have to be separated. They use a sifter to get out unwanted rubbish. Recuperated rubber particles purged of foreign materials measure about 2.5 millimeters. Some 16 tons of tire particles are piled up in this recycling depot. But the particles are still too large to be used. They're sent to a secondary shredder's supply tank, where they'll be reduced even further. This tractor feeds the secondary shredder. Grinding action produces a kind of rubber powder. The powder is spread out on these enormous molds. This mold has a length of 7 meters and a width of 1.2 meters. Thickness varies according to the product being made. The molds filled with rubber powder are stored in this loading magazine of the press. Once full, the molds are sent to the rubber mat press. Here's the mat press. The powder has to be cooked at a very high temperature for about 30 minutes. Cooking time depends on the product being made. The cooked mat goes through the unmolding unit before being sent off to cool. The rubber mats are still extremely hot. They're cooled with jets of water for a period of several minutes. The cooled mats can now be sent to the next department. This conveyor in the cutting center positions the mat before it's cut. The mat is vibrated to eliminate any surplus water. Each rubber mat is now cut up into 3 pieces. The cut mats are then stacked into a pile and stored before being shipped. The company also makes mud guards. These are fabricated the same way as the preceding mats. After having been cooled in water, but while they're still warm, they remove the surplus rubber. This operation is called notching. Hard rubber rings are also produced at this facility with the same fabrication methods and, as always, from old, used tires. Over a 12-hour period, this facility makes no less than 12,000 rubber mats from old recycled tires. This translates into good news for our environment.
There was a time when exposing your hardwood floors meant you just couldn't afford wall-to-wall carpeting. Not anymore. Hardwood floors are definitely in. And today there are so many wood and stain color choices, hardwood floors can suit any decor. The types of wood commonly used for flooring include red oak, beech, maple, white oak, walnut, birch, and ash. As soon as the wood arrives from the sawmill, workers at the floor factory stack it on racks, then pile the racks floor to ceiling in a dryer that's the size of a large barn. There, large fans circulate hot air around the racks. The wood's moisture content is between 40 and 60%, depending on the season. When that drops to about 7%, the wood is ready to come out. This drying process takes anywhere from 10 days to a month. The length of time varies because some species dry out much slower than others. The wood is in random lengths and widths, so the first step after drying is to cut it to standard sizes. On the way to the ripsaw, the planks pass under an optical device called an optimizer. In mere seconds, it reads the dimensions of each plank and sends that information to a computer. The computer calculates the greatest number of standard-sized pieces that can be cut from the plank, then guides the ripsaw to cut accordingly. This maximizes the yield and limits waste. Flooring is made from medium quality rather than top quality lumber to keep prices competitive. As the pieces exit the saw, workers manually cut out any large knots or other defects, weak points at which a piece could potentially snap and jam up the equipment. The pieces now travel to a machine called the molder. Its revolving steel knives spin at a rate of 6,000 rotations per minute, carving a tongue down one side of each piece and a groove down the other. Workers do frequent spot checks to make sure the tongues and grooves fit together snugly. The next machine carves grooves on what will be the underside of the pieces. This is for air circulation and stability. Then, an embossed wheel imprints the words, "Made in Canada." Using cross-cut saws, workers remove any faults in the wood and divide pieces that have noticeable color variations. This is the first step towards sorting the wood by grade. Now a machine called an end matcher carves a tongue and groove on the two ends. Here's the view from inside the machine. Workers check once again for faults. Then, assessing quality and color, sort each piece by grade. This will be pre-finished flooring, so the pieces now run through a sander to prepare them to receive 8 coats of varnish. For certain finishes, the first coat contains wood stain. All subsequent coats are colorless. Between each application, ultraviolet lamps dry the varnish in just a few seconds. As the flooring exits the last drying oven, it's ready for packaging. Unfinished hardwood flooring has to be sanded, stained, and varnished after it's installed. Pre-finished flooring eliminates that extra work, sparing you the dust, the drying time, and the smell.
The next time you bite into a marshmallow cookie, you can thank the ancient Egyptians. They invented marshmallow candy by thickening honey with sap from the root of the marshmallow plant, a herb that grows in salt marshes and along large bodies of water. Modern marshmallow contains gelatin instead of sap from the mallow root. The snap test, to make sure the coating is hard and thick enough. Then, the taste test. If you've got a sweet tooth, doing quality control in the marshmallow cookie factory is your dream job. To make a batch of dough for the cookie base, they mix wheat flour, salt, baking soda and powder, cornstarch, whey powder, and potassium sorbate. Then they add several liquid ingredients. This one causes a chemical reaction, making the biscuit lighter. This cream-colored liquid is vegetable oil shortening. This transparent liquid is glucose fructose, a sweetener. The ingredient proportions are also a company secret. From the mixer, the dough goes into a machine called the chipper. It shreds the big blob into pieces about the size of the cap on a highlighter pen. This makes the dough more manageable for the next machine, called a rotary mold. Inside that machine, a large roller flattens the dough pieces, forming them into a dense sheet about 1.5 centimeters thick. It then presses the sheet against another roller, whose surface is a cookie mold. The factory uses the rotary mold machine for many different types of cookies. It simply installs the appropriate roller for the cookie in production. For marshmallow cookie bases, the mold cavities are round. The bases exit the rotary mold and make their way onto a moving baking sheet that transports them to an oven. The baking time and temperature are, once again, top secret. The baked cookie bases exit the oven and move onto a conveyor belt that transports them to a cooling area. Once they cool to room temperature, the bases go into a machine called the base feeder. It lines them up like marching soldiers to receive their marshmallow filling and chocolate coating. The process does require military precision. Factory technicians have to adjust this machine daily to ensure to-the-millimeter accuracy. A portion of filling has to land perfectly centered on each base, finishing off in a curled peak, this brand's trademark. The company won't divulge how much marshmallow filling goes into each cookie, nor will it reveal its marshmallow recipe. But marshmallow is usually made from either corn syrup or sugar and gelatin. And now for the final layer, the chocolate coating. Not only are the marshmallow and base covered in hot melted chocolate, the base floats in it, which coats the underside as well. Built-in air jets blow off the excess. The chocolate hardens inside a cooling tunnel. How long that takes and the tunnel temperature are, you guessed it, classified information. As the cookies exit the cooling tunnel, a quality control worker does spot checks to ensure the coating is thorough, hard enough, and thick enough. On the packaging line, the cookies go into plastic trays. To keep up to speed, the workers have to grab 4 cookies in each hand without breaking the coating. The trays pass through a machine that wraps them in plastic film. This keeps the cookies fresh and also prevents them from falling out of the tray. Meanwhile, another machine assembles the boxes, first folding and gluing one end shut. Once workers load the trays, the machine glues the open end closed as well. Then, with the go-ahead from quality control, the box's next stop is the cookie aisle of your local supermarket.
Like all cheeses, mozzarella starts from milk. To assure good milk quality, the interior and exterior of tank trucks transporting milk must be washed after being emptied. A tank such as this one can carry an average of 30,000 liters of raw milk at a temperature of 3 or 4 degrees centigrade. Raw milk destined for cheese making contains 3.8% fats and 3.3% proteins. They store the milk and whey, a milk byproduct, in these immense silos, each with a capacity of 225,000 liters. This milk separator extracts surplus cream to adjust the percentage of fat according to the type of cheese to be made. Fabrication begins with this tank, which feeds the pasteurizer. Pasteurization sterilizes beverages which can easily ferment. Milk samples are drawn off to precisely determine their milk fat and protein content. Tests are carried out in this laboratory where they impose controls. These test tubes contain milk samples which will undergo microbiological analysis. Milk quality must be impeccable. This is a curdler with a 25,000-liter capacity into which milk and other essential ingredients for making mozzarella are introduced, such as the enzyme rennet that curdles the milk. This mix must be well stirred and cooked. The agitators are used to cut the whey into little lumps. This step takes about 30 minutes. The temperature of the tanks depends on the type of cheese they're making. Agitators continue stirring the milk. Once cooking is done, the whey is pumped onto tables to be drained. It stays there for about 25 minutes. The solid and the liquid are now well separated. The liquid we see draining is called lactose serum. The lactose serum will be concentrated and transformed into milk byproducts. The water has been almost entirely extracted and the cheese particles are now sufficiently dry. This large automated blade then moves cheese particles towards the next step. That is, toward the molder. In the molder, the cheese is cut up before being carried to the cooker, the final processing step. It appears that this mozzarella has just the right texture. The cheese finally arrives at the molder, which will give it the proper shape. Each mold has a 2.5 kilo capacity and is rectangular. Brine, a salt solution, serves to cool as well as to salt the cheese blocks. The blocks are unmolded and fall into a brine tank. Following on, the cheese blocks will remain in another brine solution for a while. They are then carried by a conveyor towards another tank, where they will be immersed for 4 to 10 hours at a temperature of 2 degrees centigrade. Sprays of brine remove the foam which forms at the surface of the tank. The 30,000 liters of milk that we saw coming in by truck at the beginning have enabled them to produce some 1,400 blocks of cheese in only 8 to 12 hours. The cheese blocks are finally vacuum packed, ready for shipment.